Hey guys, so this video is going to introduce the next set of lessons you're about to begin. And this set of lessons is on logarithmic equations. So that word should sound familiar from last year, but I realize it's been a while. So we're going to look at two problems here that are going to kind of connect our next unit to the stuff we've already studied so far. So here in this first problem, this problem is going to seem familiar. These are like the ones we've done over the past two little mini units. Say your rich uncle invests $90,000 into an account that earns 4.6% interest, compounded annually, for your college fund. So that's nice. Your uncle is nice. How much will you have in 2 years when it's time to write the first check? Okay. So we know how to do this math, right? I'm going to use that same function that we always use. A times 1 plus the rate to the t. And because it's compounded annually, we don't need to worry about the compounding period or any of that. So what I'm going to do here is I'm going to plug in a couple of my given. So I'm given $90,000. That's my starting value. That's my A. And then I'm giving my 4.6%. Remember, that's 0.046. And I'll plug those in. So I'll get y equals 90,000. And then 1 plus 0.046 down here to the t. And then I can simplify that if I want. And then my question for you is, what's my next step here to solve this? You guys definitely know what the answer is. So you should have said plug in t, right? I'm sure. Or plug 2 into t, I should say. I'm sure that you got that correct. Right? So remember, t is years, y is dollars, right? So in this case, if we want to find out the value in 2 years, we'll plug 2 in for t. And I get, let's see what we get here. So I get 98,470 bucks and some cents, 44 cents. Okay, so that is a type of problem that you already know how to do from our last couple units. Now we're going to tackle something a little bit different. And I'm about to ask you how we are going to go about this. So like what the difference between this problem is down here and the original problem. So in this problem, we're making the same investment. Rich uncle makes the same investment. So I'm going to use the same function as before, right? So same investment, same function. 90,000 times 1.046 to the t power. But here, we don't want to touch the money until it's worth at least $221,000. The question is, how long would I need to wait? How long would I need to wait? So I guess the question here is, what should I plug in and where? So what you should have said, and you're kind of guessing here, but I bet a lot of you got it. What you should have said is you're plugging in 221,000 to your y this time. Or 221,200 rather to your y. Okay. So that is the difference between this problem and the last problem. Okay. Now what happens is, because our variable of interest is an exponent, we have to do some interesting math to get there. So the first thing I'm going to do is I'm going to divide on both sides, and I get 2.45 when I divide 221,000 by 90,000. So 2.45 equals 1.046 to the t power. Okay, and this is what's new. So we have this equation where the variable is in the exponent, and we need to work on an operation that's going to get that variable out of the exponent. So the goal is still to isolate that variable to figure out what is t equal to, but none of our usual operations, so addition, subtraction, multiplication, or division, is going to get us there. Our next step here's where we see something familiar from last year, is to take the log of both sides. Take the log of both sides. Okay. And we're not going to solve it from here because it's going to take us a couple of lessons to get to the point where we know what the move is. But this logarithm, that is the new operation. Okay, so that's what we're interested in. And I will give you to close this fact. So logarithms and exponents are inverse operations. Okay? So the reason that logarithms are important is because it allows us to solve equations involving exponents.